Hey guys, welcome back with another legit coding activity, part 2. So in part 1, thank you. So in part 1 we talked about how to make a stack and what a linked list is. And so in part 2 we're going to finish creating this linked list. Now, I know many of you are loading your eclipses and loading your computers, so let's just do a little design work while we're doing it. We're going to do the pop. The pop function, let's see if I can get this thing to work with my fingers. Pop function. Ooh, it's faster. Look at that. Pop function. We'll have your linked list. Oops. Oh, it's much faster with fingers. I like this touchscreen stuff. It will take the top guy off the linked list, take the value out, return the value, destroy that top node, and point root at the next node down. So let's write down the steps again. I'm going to use the text to do that. One, we need to get the top value out. And remember it. 2, we're going to point root at the next element. But there's something I forgot, right? Number 0. Check if there is something to pop. So those are the 3 steps we want to do. Again, our linked list has a whole bunch of nodes. Root points to the first node. We have a value in the first node. We need to check to see if that node exists. If it does, then we remove that value and remember it. Then we point root at the next value. One of the things that happens is if a class object, such as the first node, is no longer referenced by any reference variable, then Java will garbage collect it, will throw it away. So once we move root to the second node, the first node no longer has a reference to it, and the first node will be reclaimed. Do note that the third node has a reference from the second node. So the third node will not be reclaimed, and so on. So that's how Java does garbage collection or manages its memory, is that if an instance does not have a reference variable using it, that instance is reclaimed. Okay, we see what we want to do. It doesn't say what to do with pop if there's nothing to pop. So he gets and removes the value from the top to the stack. So what do you want to do if there's nothing there? If not there, what do you want to do? Yeah, if it's null, what do you want to do?
You gotta put something there.
Put something there?
Replace it.
So pop returns a double, but if you're popping an empty stack, what should happen?
It should give you an error message saying you're popping nothing.
Okay, error message. So we're going to throw something. Let's do that. All right. Okay, so let's look at our eclipses. How many of you are still loading your eclipses? Can you show of hand? Okay, thank you. So just one. So we're going to make this pop function. We got push working. So let's do pop. Let's do pop right before toString. Okay. How do I make my pop function? What's the signature? Private, is it private? Private, double, pop.
Is it double inside?
Return some kind of double. All right, so we have some kind of double to return. Return double. We're going to start at 0, or whatever you want to. Then we're going to check to see, oopsie, that's a double. All right, let's write down our steps in comments next to pop. Where'd our steps go? Here we go. 0, check if there's something to pop. If there's not there, throw an error. Get the top value and remember it. Point the root to the next element, and we need to return that remembered value. So here I've got a value to remember it. I need to see if there's something to pop. So if, how do I check to see if the stack is empty? Where is the stack pointed at? How does the my stack get to the linked list? Yeah, what's the pointer's name? What's this thingy? Root. Okay, so here's root, and this my stack owns root, and root points to the first thing. If that has nothing there, what's the value in root? Null. If root is null, then there's nothing there. And we want to throw an exception here. Throw. What kind of exception do we want? I don't know. Let's just do exception. New exception. Nothing there to pop. That's mad at me. Why is it mad at me? Unhandled exception type exception. Add throws declaration. Okay. Now it's happy. Okay, so we see if there's nothing to pop and we're trying to pop something, it's going to throw an exception called nothing there to pop. All right, so now there's something to pop. What do we do next? Get top value, remember it. Did I say remember right? I did not. Remember. That doesn't matter. Remember. And remember it. All right, so let's add these things in. So we want to 0, check if something to pop, throw if nothing. We've done that one. Number 1, get the top double and remember it. 2, point root at the next node. And then 3, return the remembered double. So we're on step 1. How do I get the top double and remember it? How do I get at that double? Where is it? Let's move this thing over here. Where's that top value? This V that I want to get out. How do I get to it? Root will point at it. So we're going to use root. We're going to remember it. So we're going to remember it in the return double. And it's in root. How do I get at it? What symbol do I put right after the T of root? Dot. And there it is, value, right? That's what we want. All right, so now I got the value. I've remembered it. What's next? Point root at the next double. How do I do that? Root gets root dot next. Very good. And what's the last thing? Return a remembered double. So instead of returning 0, what do we return? Return double. All right, there's our pop. So now we need to test it. So let's go back to mystack.test, or start popping things and see what happens. So we do system.out.println popping plus mstack.pop. How many times do you want to do this? What's mad at pop? Why is it mad at pop? Something's wrong. What's wrong? Says The method from pop in my stack is not visible. What's wrong with pop? It's private. Someone told you to make it private. What should it be? Public. Very good. All right, let's see if that fixed the error. Still no error. Did I spell it right?
Yeah.
P-O-P.
Hold it there.
P-O-P. All right, let's run this anyway and see what happens. Errors exist. So what is the error? Errors, 31 items. What the?
Well, what happened, Dr. Shake?
Oh, I'm trying to compile something wrong here. Card cannot be blah, blah, blah. I want to compile this thingy.
Oh, is it stuck on the card one?
Yep, stuck on the card one.
Yeah.
So,
It's used from the drop down menu when you.
okay, so I should go run drop down, and this is the my stack test.
Now,
We run this, proceed. Exception thread main, unresolved compilation problem, unhandled exception type exception.
well, at least it's not in the card one.
So we had a exception thrown.
I think it,
M stack, why is there an exception thrown? M stack should print. How come it's throwing it here? Unhandled exception.
well, it's just gone.
All right, let's see.
That mom makes some nice butt cheeks.
All right, I'm going to comment this out and see what happens.
That is a male or female mom.
I'm going to try to find out where the error is.
Like, what? Oh.
There's still an error. Why is there an error? There is no pop. I thought I just made a pop in my stack. Oh, I commented it out. That's right. There's no pop anymore. All right, let's run this, see what happens. All right, and then let's get pop to come back in. Public double pop, throws exception, fruit is null, throw an exception, whereas root gets root next. Return double. I don't see anything wrong here. If root is null, throw new exception, okay? And then in the stack test, popping M stack. Now I have a pop. And let's see what's wrong with the pop. Pop says unhandled exception type. Maybe we have to try to handle the exception. Maybe it's mad at me because I'm not handling the exception. We'll do a try. Try. Catch.
Finally opens up and it's not responding.
Exception E. System.out.println error plus E dot get message. All right, so happy now? It's how I guess we have to catch and handle every exception we create. We can't just let it go to the operating system. That's stupid. Okay, let's run this, see what happens. Popping, minus 2.53, so we can pop everything. Let's pop a whole bunch of things. How many things did we push? 3 things. So let's pop 4 times, see what happens. Okay, so we have a push test. We push 3 things in. Pop test, the 3 things should come back out. Let's see, 1, 2, 3, and when we pop the 4th time, nothing there to pop. We get an error. Okay, the pop is working. What's next? Where did it go? Oh, it's in my, here we go. It's over here. Here we go. So we got push working, we got pop working, we got toString entering. What's the size thingy do? Reports how many elements are in the stack. How are we going to do that? There's two ways. There's a nice quick way, and then there's the slow way. Which one do you want to do? The quick way. The slow way? All right, so we need to make the size thingy work. And the thing we're making is called size. It's an int, public, int, size. And all it does is returns the size, returns how many elements are in the stack. How are we going to do that? The question is, how are we going to find out how many elements are in the stack to return size? So let me go over here and fix this thing. Where am I? Home, image, select. Make this go away. Time to do size. How do I return the size of my stack? Ooh. Is it 0? Is it 0 that I'm returning? How do I find out how many are in there? Any ideas? Counts. Okay, go ahead. Counts the nodes, elements. What do you want to call them? Round things, chains, things? Nodes, okay. Counts the nodes. All right, so how are we going to count the nodes? A loop, okay.
Can you scroll down a little?
Sure. You want to count the nodes with a loop. So you can use a loop to count nodes. So what kind of loop do we want?
Which type of loop?
We have 4. What else? What other loops do we have? While. And do while. Which one do we want to use? Want to use a 4? Okay, we'll use a for loop. How do I use a for loop?
Right, 4.
Okay.
What? What's already there? Where? You mean in the sentence?
4, comma, comma.
It is called for.
What do I put in the initialization spot of the for loop, if anything? Sorry, what? There's 3 parts to a for loop. There's an initialization part that goes before the first semicolon. There's a conditional that goes between the 2 semicolons. And then there's an increment part that goes after the semicolon. Do I just leave it blank?
No.
Int I equals 0, okay. What's next? I is less than what? Less than or equal to what? We want to loop through all the nodes. Any idea, Quadro? Loop through all the nodes? Yeah, how do we do that? A for loop?
Yes.
Okay, then so far we have 4 int I equals 0. I is less than or equal, and we have no idea what to go there. What goes there? Jeffrey?
Should we use a while loop?
A while loop. Okay, Jeffrey thinks a while loop would be better.
Can we, is this so like because we don't know where it's ending?
Exactly, we don't know where it's ending.
Why did we say 4 then?
Have we used the while loop to iterate through before?
Yes.
What does our printer do? Prints what? All the values?
No. Everything that's
Everything in the list, right? How does it find everything in the list? Does it loop through them all?
Come on, guys. So what happened? They logged it in.
They locked it again. Okie dokie.
Come on now, man. You are the vegetable. I have no fruit, you vegetable.
I had no fruit.
Grocery market battle right now. Fruits against vegetables.
Expose them on TV.
Yeah, expose them on YouTube.
Yeah, you said you
All right, let's see. Numbers 23, 15, and 6. I do not know which one of those it is.
Who's 23? Do we even have 23 people in this class?
No, but somebody is sitting at computer number 23.
Bro, it's probably one.
All right. All right, so let's continue. Oh, I have to unlock everyone. Sorry.
You can continue.
I can continue without unlocking people. Okay, here we go. Okay, they should be unlocked. Again, please do not play with settings. Please do not do Roblox, and please do not do bullet force. See what we got here.
Hey, who's number 15 though? Sean?
15, yes.
Is that Sean?
It's going to take a while to find it, so let's just skip this. Move on. Find the naughty person. Okay, is there a loop in the 2-string? There is a loop right here in line 64. We use a while loop. And then on line 72, we move to the next one. So those two together will iterate through all the things.
So we just do the same thing there?
We do the same thing, just to count, right? We're counting. So instead of for loop, we can use a while loop. We need some kind of iterator.
Wasn't it called iterator?
Shall we do a for loop instead? Let's do a for loop.
Let's try it.
For
Wait, what?
node it equals root. Node is not equal to null. Node equals node dot, I'm sorry, not node, what is it called? It equals it dot next. So here is the same while loop we saw before, but now it's in a for loop. What a deal. And what do? We need to count. Oopsie, what did I do? Get class. Where did that come from?
Yeah, autofills, right?
Yeah. Count.
And sometimes you just go back and be like, I had that.
Okay, gentlemen, ladies and gentlemen, how do I count?
Incrementing?
I increment something. What do I increment?
It'd be it, right?
I increment it.
Plus.
It's a node. Do I increment it? No. What do I increment?
A new variable.
A new variable. Where do I put that new variable? In the for loop or outside the for loop? Outside. Why outside? Let's call it C for count. What do we return?
Is it C?
C. There we go. Finito. So this is the slow way to count. The faster way is to keep a running total of size and return it. We don't have to do the fast way. We got a slow way. I'm going to leave the fast way to you. Every time we push, pop will reduce the size, and every time we push, we increment the size. And size should start at 0, and then size is returned by size. And that's the faster way, because we don't keep iterating through the whole loop to count it every time we need size. Okay, let's test it. How do I test size? Let's do it up here somewhere. Let's do it here. System.out.println size plus mstack dot size. And after we pap twice, let's do the size again. Okay, let's run this, see what we get. So I just added 2 size tests to make sure they change and I get the right sizes. So when I have 3 things in, size is 3. When I have 1 thing in, size is 1. What about when I have nothing in? And after I'm done popping, let's put the size in here. And let's put it after I popped everything. All right, let's run this again. Let's make sure our size is working. When I create a new one that's empty, size is 0. When I've popped everything out, size is still 0. Yay. When it has 1 thing in, size is 1. When it has 3 things in, size is 3. Size is working. What's next to do? Last thing to do, what's this one called? Empty. I need a function to empty the stack. So we go back to the stack. We make an empty function. Public void empty. And empty's job says it right here. Empties all the elements from the stack. This is really easy. How do I empty all the elements from the stack?
You pop all of it?
Pop all of it. Is there a faster way? A much faster way. Exactly. Make root equal to no. That's all we need to do. Make root null. Root equals null. Done. All right, let's see if we get this thing to work. We need to test it. So in order to test it, we have to push stuff on the stack and then make it empty.
What's the difference from all the different try catches you have there?
Sorry, what's the question?
The difference from all the try catches you have like 3 sets, right?
Yeah, so for I'm just doing it separately. For each pop I try, I put it in a separate try catch. I could put all the pops in one try catch and just have 1 catch and 1 try and 4 pops. That would do the same thing.
So the thing is that's different in what you input. Is that it says a different exception?
Yeah, so each exception, when pop throws an exception, it's a new exception and it's caught. All these are saying we're going to catch an exception. We're going to call it E so we can use it in the catch statement. So here I'm using E. If I don't catch anything, if I just do dot, 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 I won't be able to get the E. So this, oopsie, args.
Make that message. Yes.
How come it's not doing 3 ellipses? Bastards. I don't want dot. Oh, I can see if I can try it. Let's see. I cannot do 3 ellipses. Oh well. Some languages you can do 3 ellipses. That means catch everything. But apparently not here. All right, I need to fill it up so I can empty it.
Yes.
So after all my things, I need to push 3 values. Let's do 1.234 and then 2.345 and then we know our push works. We've tested it already. 3.456. And then we're going to pop it. So let's print, see what we have. This is B4 empty. And we empty. And then after empty. Let's just grab line 62, copy it, paste it on 64, change from before to after. Okay, so here's my empty test. I put stuff in to see. I look at it, I empty it, I look at it again. See what it looks like. Before empty, I have three things. After empty is empty. Perfect. Now we are done. Is there anyone who would like me to show you something?
Please get the size.
The size one again. Okay. That's my MJ. So here's size. I see a for loop, which is the same as a while loop. In the for loop, I create a new variable called it, which is a node. It points to references the same node that root references. If it is null, I'm done. As long as it references something real, we keep going. I increment my counter. My counter starts at 0. And then for the incrementer, it gets to the next node. So eventually it finds null. When it finds null, then we exit the loop and we return C. That's size. Notice I used the for loop. You can easily use a while loop.
Can you go through your tester?
Tester. What would you like to see in the tester? Would you like me to scroll through it?
Yes, please.
All right. So in the tester, I want to test every logical pathway through every public member of the interface. So the first one I'm testing is the default constructor, which I did not create, but a default constructor does exist. When the default constructor fires, the only variable currently in my stack is the root variable, and root will be set to null. So we get root null. Then I print the stack. That will call the toString. The toString will iterate through the stack, all the nodes in the stack, printing the doubles in those nodes. I create a double value for my pushes. I show the size of the empty stack. That should actually be moved up 1. So that goes with this. I set my value to 2.53. I push it, and I print that I just pushed this value, and the stack, print what the stack looks like. I push 3 times, showing a different value each time I push. I then check the size of the stack. Now it's time to pop. I pop 4 times, but pop can throw an error. Since pop can throw an exception, I must put my pops in a try-catch block.
Why did you say earlier the ellipses?
Some languages allow you to catch anything by putting ellipses here. So right now I'm catching anything that is an exception, which is all the exceptions.
So, but that's just the same thing 4 times, right?
Yes. So it's the same thing 4 times. I'm popping 4 times, but I only have 3 things in the stack. So 3 of the 4 times I actually pop a real node, and the last time I get my error message. Jeffrey?
So do you have to write a new try and catch block?
No.
Which one?
No. So I could have put all my statements, all my pops, in a single try with a single catch.
Boy.
Okay, so I pop 4 times. Only 3 of them work. The 4th one throws an error. Then I print the size. I've popped everything, right? So I start at 0. I put stuff in. I got the 3. I pop stuff out. I'm back to 0. Then we want to test our empty. I push 3 things in the stack. I look at it. I call my empty and look at it again. And that's the test. So let's make sure I've tested every logical pathway through the stack. I have push. I have double. I have size. I have empty. All 4 of those have been tested. The default constructor has been tested, and the toString has been tested. So I've written my stack class that holds doubles. To do it, I played with nodes. I wrote a tester to thoroughly test all my methods in the stack. Unit test tests every logical pathway through every method in the public interface. All right, is there any other questions? All right, good. I can end the recording. Bye, y'all.